Everybody, it's Stephen Feuerstein with In Some Solutions here to talk to you about PL/SQL, because what else would I talk about? Well, I guess in a lot of these sessions, I actually start off by doing a bunch of ranting about the state of the world and so on. You know what? I'm going to spare us all because there's just there's just too much to rant about. Where would you start? So we'll just dive into PL/SQL and have some fun with that. So what I thought I would do today is talk about collections, the different types of collections. I know I've talked about collections before and various collection-related features. A lot of this may be repeated from previous Feuertips, things you've heard, but then it might be nice to just do a little review. So, and I'm going to try something really new and exciting, which is the same browser for my demonstration of code. So could you share my screen, Mark? And I'm going to make this go away, right? So now I think, does that look okay now? We don't see infinite mirrors. So let's talk about collections and the different types of collections there are. It's interesting. Obviously, PL/SQL goes way back, essentially really to Oracle 7. That's when PL/SQL really took hold with packages and the first iteration of collections. And it's since progressed over time. And, you know, a lot of PL/SQL, I think, is very elegantly designed. And they spend a lot of time thinking through the language and how to add pieces to it. But of course, when you build things incrementally and add things incrementally, you can end up with a kind of a fractured, confusing environment. And that's where I think we stand with collections. So collections are essentially in-memory tables or arrays for PL/SQL. And you can think of them as being the PL/SQL version of tables, which could explain some of the syntax behind PL/SQL collections. So we'll do a little history. Way back in Oracle 7.3 or Oracle 7 something, collections were introduced to PL/SQL. And back then there was just one type of collection. It was called a PL/SQL table. And here you see the syntax for declaring a new type of data, a new type of PL/SQL table. You give it a name, is table of. So that goes back all the way back to Oracle 7 syntax of PL/SQL tables. The data type of every element in the collection, this is a table of strings or an array of strings, and the indexing mechanism. So this is the very first kind of PL/SQL collection. It was called a PL/SQL table. And it lets you do a number of things, and it didn't have a whole lot of functionality actually initially, but what was really exciting is that in 7.3.4, I remember the moment so well, the upgrade to 7.3.4 introduced collection methods. So believe it or not, prior to that release, back into 7.3 something, or maybe 7.2, you could fill a collection. We'll take a look at the code to do that. But you couldn't even ask for things like how many elements are in the collection. You would literally iterate through the collection until you got an exception, couldn't find any more. That gave you the number. And what was also interesting is that all of these collection methods were defined in a package called PLIT-BOLM. So let's take a look at the PLIT-BOLM package. Here's my little query that I saved from years and years ago. Let's go over to, no, we're going to stay right here. And we're going to go to Live SQL. Hopefully I'm still connected. Let's see. Start coding. There's my query just from before. So I'm going to run this query. So it's going out to the sys schema. So it's one of the system-owned packages. PLIT-BOLM, type is package, which is specification. And I don't remember what original con ID is. And here's the package. So what's interesting is that it actually declares the functions, the methods on collections. So, and if you're familiar with looking at any of the built-in supplied packages from Oracle, like the standard package, you'll know that this is a PL/SQL package, but they cheat and they do things that we can't do. Like here, count is a function that takes, well, any kind of collection and returns a binary integer. Function first, return the first element in the collection. So anyway, I think it's just kind of curious that all these methods were actually defined in this package. I assume you need the package there to make the methods work, but I've never tried deleting it or anything. So back in 7.3.4, you had this first release of collections. Back then we called them PL/SQL tables. Today they're called associative arrays. So let's go exploring with associative arrays or PL/SQL tables. Then we'll move on to the other two types, because the interesting and confusing thing about collections is that there are three different types, three at least minor differences in syntax, different characteristics for each type, and it's worthwhile knowing which to use when, which is the kind of what I'm going to cover today. So I'm not going to get into great detail about all the different ways that collections are used, but kind of focus on those different characteristics. So let's grab all this code and go to Live SQL. I can only get my windows right. And back to code some SQL. So what I'm going to do here is declare a new data type inside my PL SQL block. I declare a variable based on that type. So it's a list of names. And then I can populate my collection. So one of the first things and one of the most interesting things about associative arrays or PL SQL tables is that you can fill them sparsely. So I can just assign values to whatever element in that array I want, from -2 to the 31st plus 1 to 2 to the 31st minus 1. Any value, go ahead and use it. So I'm just like picking them sort of out of the air. I can define them in whatever order I want. They don't have to be from the lowest number to the highest number. So just sparsely assigning values. Clearly, it's unlikely that you would ever write code that looked like this. Why would you have hard-coded values like -50,070? But primary keys are often integer values. And while often roughly sequential, if you're using a sequentially generated GUID, they don't have to be. There can be lots of sparse values in your primary key set. So in that case, something like a sparse index in my collection is really helpful if I want to mimic primary key indexing within my collection indexing. Okay, so I can just populate them however I want to. They can be as sparse as I like. I have a bunch of methods that I can say that gives me information about the collection or lets me change them. So get me the number of elements in the collection. Then I can iterate through from first to last, from the very beginning to the ending by using the navigation methods like first and last, prior. And so in this case, what I'm saying is, get me the last defined index value. While that index value is not null, I'm going to get the value at that location in the index and show you that person's name. And then I'm going to go backwards using the prior method, get me the previous index value. And if I wanted to go forward, I would start at first and go to next. And then we'll run this. Invalid statement. Let's see, did I have something highlighted? There we go. So you can see that I went from the highest down to the lowest index, showing the names in that array, the elements in that array. And if I want to, I can just switch the order. Now they should come out the other way. Here we go. So the methods give you the ability to iterate through the collection. These methods are not specific to associative arrays. In fact, the only real thing we've got here that's specific to associative arrays is the fact that I've got an index by clause, which you're about to see is only for associative arrays or PL SQL tables, and my ability to just assign values sparsely. Now, the other super cool thing about associative arrays is string indexing. Let's see. Does that help me out? Let's just go to my string tracker package. So one of the really nicest things about associative arrays, and the reason you're most likely to use these instead of the other types, is that you can index not only by PL SQL integer, PLS integer, but you can also index by varchar2. In this case, I'm indexing by a subtype because I find it very useful to give these names so I can say what I'm indexing by. Usually if I'm indexing by a string, there's a specific thing I'm indexing by, the name or the location or whatever it is. So I often give it a name so it reminds me every time I use it as to what that indexing value represents. But the nice thing about it is I can index by string or integer, which is not true of the others. So I'm going to go through the different types, then we'll come back and look at how some of these can be really useful in different ways. So associative arrays are when you have the index by clause. Now let's take a look at nested tables. So the first round of collections introduced in Oracle 7. In Oracle 8, Oracle added the object relational or the object side of the object relational model of Oracle database, Probably one of the least useful introductions ever in Oracle technology, though it's certainly used pretty heavily now in a variety of ways. But it was an effort to meet, I would say, pundit demands that relational is not enough, object orientation is really exciting, you should have it in your database too. So that Oracle added a number of object-oriented features. And two of those features were two new types of collections, the nested table and the V-array. And now, Mark, you just interrupt me if I have a topic to look at, a question or anything, comment to look at, because it looks like I'm just going to talk for a while. Now, with a nested table, so you have associative arrays, they're actually called PL/SQL tables. Then in Oracle 8, Oracle introduced nested tables, at which point PL/SQL tables were then called index by tables because you have index by clause. With a nested table, you drop the index by clause. You just say, hey, this is a table of strings or a table of numbers or a table of dates. This is part of the object relational model, as is the third type called the V-array. And because it's part of the object side of this modeling, there are some more rules associated with it. It acts more like an object or a set of objects. And in fact, one of the key things about nested tables is their set-oriented properties. So hopefully you're aware that the SQL language is set-oriented and declarative. So I declare the set of data I want to see. The underlying engine figures out how to get it. Or I specify the type of changes I want to make to the data. And the changes are made for me without me writing an algorithm to figure out how to apply those changes. So we have SQL is set-oriented, declarative. PL/SQL is more procedural-oriented. That's where you get into challenges around row-by-row processing, because a lot of the algorithmic controls inside PL/SQL are sort of row-by-row, algorithmically determined as opposed to set. You can think of that here too. In a way, associative arrays are more of the procedural PL/SQL non-set-oriented type of collection, whereas nested tables, and similarly V-arrays, but as I'm about to go over with you, that you'll almost never use them. Nested tables were designed to be true set operations or true set data sets to be manipulated with set logic. So you can use them a lot like associative arrays, but the real power of nested tables is that set orientation. Now, specifically, nested tables are multisets. And a multiset is a set of data in which rows can be duplicates. That's the multiple. You can have multiples of the same values in your rows. And there's no inherent order to the rows in the table, which is what a relational table is. If you don't have a unique index on a relational table, it's a multiset. You can have as many duplicates as you want, and there's no inherent order without actually requesting an order by. Nested tables are multisets in that same sense as well. And you can see that in the kind of things you can do with nested tables. So with associative arrays, you're almost always doing programmatic operations, procedural operations, iterating through algorithms. With nested tables, you can do similar things, but you can also do this set feature. So let's take a look at some of that. So I'm going to declare a list of names as a schema level type. Notice this is a type within in my declaration section. This is a PL/SQL only type. With nested tables and V-arrays, I can declare them at the schema level. They're essentially known to the SQL layer, which becomes really important in a number of ways, as you'll see. So I can declare my happy family, which is a list of names. Now, with a nested table, because it's part of the object model, I have to initialize it before I use it in most situations. So each of these different types comes with a constructor function of the same name. And that allows me to basically initialize it or even populate it. So I could say, right inside my constructor function, I could say Joe, only I could type Sally, etc. Right there. I can literally initialize my collection with multiple elements. If I don't do that, it's initialized but empty. And then I can assign values to it. Now, remember, with associative arrays, I could just put values wherever I want. It's inherently sparse. Nested tables are inherently dense. In fact, there's nothing in there. There's no place you can put things unless you explicitly extend and make room in the array. So here I'm saying I've got 7 members of the immediate family. I want to extend bulk. I'm going to extend 7 locations. That defines index locations 1 through 7. You don't have any choice about this. And then I can assign values to them. I can also extend individually and just assign values into the new last element. So again, usually you're not going to hard code things like this, but you can do it either way. The point is that if you don't, as we're about to see, you end up with errors. So let's create this type. There's my new type. And let's take this code. We'll just run the whole thing. That's too much at once. Okay, so let's do this. And I run it. And it populated those 7 rows in the collection, and then it ended and it released the memory for my collection. Now what happens if I take this out? Subscript beyond count. So when you get a subscript beyond count error in your code, you run your application, you get this subscript issue, then go look for nested tables or VArrays. And what you want to look for is assigning values to index values, locations in the array that have not yet been defined. Here, nothing's been extended yet. So even 1 does not exist. And notice it pointed to line 9. Let's now extend 5. So now we got subscript beyond count at line 14, right? We got the first 5 assigned, okay, but not the next one. So the point here is that when you switch to nested arrays, you're going to get a number of interesting benefits, but you also have to pay a lot more attention to the code you're writing. You can't just declare it, use it any way you want to. You have to basically make sure it's initialized, extend as needed to fill it up. But you get some really nice benefits. So specifically, the most important thing by far is the set-oriented capabilities. So just like you can do union, union all, intersect, minus in SQL with tables, you can do the same kind of operations on nested tables using the multi-set operators. And this, by the way, can be done in SQL. If you have nested tables defined in SQL, you can use multi-set operations within SQL as well as PL SQL. So what I've done here is said, okay, here's my full immediate family, all 7 of us. Here's the children, Chris, Eli, and Lauren. Then I have grandchildren, Loie and Juna. So I've created 3 different sets of data. Well, what I'm saying here is take the happy family and minus. For some reason, they didn't use the word minus. They used the word except. But it's the same thing. Take away the children. So that should leave us with the grandparents and the parents. And then take away the grandchildren. Sorry, that would leave us with the grandparents and the grandchildren. Take away the grandchildren, and that should leave just the grandparents, the super parents. And then we can iterate through that array and find and see the results. Here's an example of using the delete method. Again, that's available for associative arrays and for nested tables, and to a limited extent with VArrays. And I can delete elements from the end of the list and then add them on as well. And then finally, the most important thing probably about nested tables, though you can now do them with associative arrays as well, is I can treat them as if they were relational tables. Hopefully you know about table functions. They're based on the same concept here, which is that a collection is really just like a relational table of rows and columns. So if I put it in the table operator, and in some cases now you don't even have to include the table operator, it basically says take this collection of elements, convert it into a relational format, and then use SQL against it. So let's grab all of this. Look, I keep doing it. There we go. So here are the 3, 4, 5, 6. So if we go back here, 1 through parents. So happy family minus the children minus the grandchildren. I'm running these 2 different things together. So these are the first 2 from the first query, from the first loop. And then we've got these from the second. So let's just put in a little differentiator. That's really hard to understand. Try that again. Just make sure I know what's going on here. There we go. So this is the double except. And then this is basically the result of a query. So go to the happy family, which now just has these 4 elements in it because I deleted everything before that. And now I can just iterate through them as if it were a relational table. And it automatically, if it's a collection of individual scalar values like strings or number of dates, the column is named column value. Okay, so let's recap. So with nested tables, you have more complexity in terms of managing and using the structures. You have to initialize them. You have to extend to make room. With some exceptions, if you're doing a select bulk collect into, Oracle will take care of that for you. But otherwise, you're micromanaging the structure. But the benefits you get are pretty enormous with things like multi-sets, with things like the table operator being able to treat them as relational tables, and some more stuff as well. So in nested tables, you can also check for equality of collections. You can ask if a element or a string, let's say, is a member of this list. And so there are a lot of high-level set-oriented opportunities for you to use with nested tables. Is it empty? You don't have to say dot count equals 0. Is it empty? Is it not empty? You can get rid of all the duplicates with a single command. So here's the way I think about this. When I'm working with collections, I'll often start, you know what, I'm going to hold off on that. Let me do V-arrays quickly. Then I'm going to do the sum up around how to think about which to use when. So the third type of collection that was added in Oracle 8 is called the V-array, which stands for varying array, which is weird because it's the least varying. It's the most fixed. When you declare the type, you declare the maximum number of elements that can be in it. As to why you would do that, there's some arguments for if you've got it as a collection in a relational table. In other words, if you've done a denormalized structure and you fit a collection into a relational table as a column, which you can do. If you have a limited number of elements, let's say the number of months in the year, you know it's never going to be greater than 12. If you define it to be a V-array, you might see some performance and memory optimizations of using that V-array as a column. But in my work as a PL SQL developer, outside of SQL, I've never used a V-array, never. But other than that, it's pretty much like a nested table. So you have to initialize, you have to extend to fill it out. You have the table operator that can be used against it, all pretty much the same. I won't bother talking more about it because, again, unless you, for some reason, know it's going to be a very restricted number of elements and you want to put the constraint on it, you're not likely to use V-arrays. So to me, on a day-to-day basis, it comes down to, well, I'm about to do collections. Should it be an associative array or a nested table? And one of the ways I think to best get the answer to that question is, as you start writing code, how does it feel? Do you feel like you're writing a lot of code that isn't necessary, that could be done more easily, that should be done by Oracle? For example, I got started using associative arrays because this code was originally written a long time ago. We didn't know about nested tables, weren't comfortable with them. So we wrote a lot of PL SQL code and a lot of procedural code to do set-oriented things like pass in the array, pass in the value. Is this value somewhere in the array? In fact, that's what string tracker is. Let's take a look at a quick demonstration of how you can end up writing too much code. This will have to do more with string indexing than anything else. And I'm sure a lot of you have seen me give this example before. But I basically want to check to see, I want to keep track of all the names that I've used for things because I'm generating code and I don't want to duplicate my variable names. So I want to mark a string as being used and then ask, is it in use? So I built a little API to do that. And what I did was probably the most initially intuitive way of doing it. So basically I kept a list of names that I used. So I've got an associative array indexed by integer. You pass in the name you want me to mark it as used, I'll add it to the list. So go to the current end of the list and add one to it. So it'll start me off in 1, 2, 3, 4, 5. So I fill up my list with all the names I've used. But then if I want to find out if the value has been used, if it's in that list, I need to iterate through, like loop through my array and look for matches. So I'd say that this would be an example where you should ask yourself, wow, seriously, Stephen, or seriously, Oracle? After being around for like 40 years, I still have to write this kind of code? Chances are, if you are able to step back and notice that you're just writing too much code, chances are there is a built-in that will do it for you. Now, in this case, there are actually two possible solutions. One is to switch to string indexing, which I'll show you in a moment. The other is to switch to member of. So what I usually do in a situation like this where I'm doing a full collection scan is I realize I'd rather do an indexed scan, just like against a table. And the problem is that I filled sequentially, so there's no information about this value in my index. My index is simply the nth value. Here's where string indexing can come into play. So instead of indexing by integer, I index by string. And then I won't go through all the details of this code, but what you can see right here is that if I want to mark a string as being used, I use that index value. I give it a value. It doesn't matter what the value is, but I mark it as now defined. And then I can simply ask, is this variable in use by saying, does this element exist in my array? I'm sorry, is this index value defined in my array? This is actually the index in the array. So in this case, I was able to use string indexing to avoid having to do this incremental population and to avoid having to do this kind of looping through my code, looping through my array to find a match. The alternative might have been to use member of instead. So I can add it sequentially if it's a nested table because the order is really not significant, and I can just say, is it in there? I should implement that as an alternative approach and test performance. In fact, I will do that. I'll try that soon. So in general, if you're working with collections and you find that it's just, you're writing too much and too complicated code and it seems like it should have been done for you, look for alternatives. So one alternative is to switch from numeric indexing, integer indexing to string indexing. But the bigger transition will be to identify to yourself that you're doing set-oriented things with your collection. And in that case, what you really want to do is take a look at removing the index by clause. Hey, now it's a nested table. Now you'd like to think that you could just do that, make that one change, and then all your code's going to work and you can just start doing member of and set and sub-multi-set. Maybe. But remember, as soon as you remove that index by clause, you now have to initialize your collections, you have to extend and so on and so forth. So there's a good chance that you will not be able to just remove your index by clause and suddenly have all these great features available without modifying your existing code. But if you can have Oracle do the heavy work for you, like comparing if two collections are the same, if this element is somewhere in the collection, wow, that's an enormous boost for you from the standpoint of productivity and code quality. All right, so let's shift off to no longer sharing my screen. Looks like it was a quiet listen. Is that right? Any comments?
No comments, Stephen, except for Judith, who wonders why you're wearing a T-shirt in North Carolina. Is it that warm?
Is it
That's
so
a nice
warm in North Carolina?
Yeah.
Well, I am inside my house. So, you know, it almost doesn't matter as humans, since we have a very strong demarcation between inside and outside. It doesn't matter, right? But the answer is it's pretty warm today. It's in the 50s. Or no, it's just coming up to 50. So it's not a very cold day. We've had, I think, one of the warmest Januaries in recorded North Carolina history. Gosh, I wonder why. So no, it's pretty warm, but it's also okay in my house, 68 degrees. Okay, so no other questions. Probably I hit on a lot of topics you already knew about. So the summary around collections is, first of all, to be aware of them and comfortable with them. They are a critical feature in any modern application development with Oracle and PL SQL. And be aware of those different types, associative array, nested table, V-array, because finding the right type will have an enormous difference in terms of the amount of code you'll end up writing. It could have a big difference on the performance of your application, right? So if you're writing a lot of detailed algorithmic code, ask yourself, can I switch my indexing method? Or maybe should I switch to the nested table and take advantage of more of the built-in functionality of Oracle? All right. Well, thanks for joining me today. My half hour is up. I hope you're all doing well, staying safe, staying warm, or staying cool, depending on where you are now. And happy PL SQL coding. See you soon. Take care, everybody.